Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is UMILASARI. I'm from Universitas Erlangga. I'm PhD student of Mathematics and Natural Sciences. Our topic research is about graph theory. This title is dominant local metric dimension of wheel-related graphs. This is my joint research with Dr. Sulawati and Professor Slamin from Jember University. Dominant local metric dimension is consists of two interesting topics in graph theory. They are dominating and metric dimension, which be expanded as local metric dimension. A graph G is said having dominant local metric dimension if G be a connected graph and there is an order subset WL equals to W1, W2 until Wn, a subset of G, where WL is a local resolving set as well as dominating set of G. Minimum cardinality of dominant local resolving set of G is called the dominant local basis of G. Then cardinality of the dominant local basis of G is called the dominant local metric dimension of G, which denoted by dim LG. In this paper, we determine the dominant local metric dimension of wheel-related graphs that are wheel, Jahangir, Rancid, and Helm graph. Furthermore, we characterize the dominant local metric dimension of this graph. This is the definition of wheel graph, Jahangir graph, Rancid, and Helm. And this is the example of the wheel graph. This is W4. W4 wheel graph with the order is equals 4 and then the number of each is equals 6. Helm graph. This is the example of Helm graph. We can expand until n. This is H3, H4 until H8. This is the example of Jahangir graph J3, n. This is J3, J3, 4. This is J3, 6. And then this is the example of Rancid graph. Dominating number of wheel-related graph. Dominating number denoted by gamma. The dominating number of wheel is equals 1. Dominating number of Jahangir is equals n. Rancid n, and then Helm dominating number is equals n. There are some definition, lemma, and theorema that used in this paper as presented below. This is the definition of dominant local metric dimension, and then some lemma. First lemma, let G be a connected graph and S subset of G. Every set S containing local resolving set is local resolving set. Next, let G be a connected graph and WL subset of G. For every VI, VG element WL, then representation of VI to WL not equals to representation of VG VG to WL. And then this is the lemma, show the lower and upper bound of dim L of G, where max dim L of G is greater than equal maximum of gamma G or dim LG. Dim LG is less than equals minimum of gamma G plus dim LG or order of VG minus 1. And then for fancy graph for n greater than equals to dim L of Fn is equals n. Fn is notation of fancy graph. This is the method. This is the method or procedure to get the dominant local method dimension of graphs. For the result that we have, first I show the lemma to prove the local resolving set of Wn plus 1 or local resolving set of wheel graph. First, I suppose the vertex set and edge set of Vn plus 1, and then I put the WL is equals V1 and V4, and then uh, I find the distance from every vertex to V1 and V4 like this. Based on the description above, for any two adjacent vertices have different representation. Therefore, WL is local resolving set of Wn plus 1 for n more than equal 6. We can see that if Wn plus 1 is a wheel graph with the order n more than equal 6 and the edge set of Vn plus 1 is equals uvi for E like this, and then uh, union vi plus 1, this is the condition of I, union vn v1, then wl equals to v1 v4 is a local resolving set of vn plus 1. This is the theorem to prove the ddml of vn plus 1. The result is selling n per 3. Selling n per 3. We divide the proof into three cases or three possibilities of n. First, if n equivalent 0 modulo 3, if n equivalent 1 modulo 3, and n if n equivalent to modulo 3. We have the cardinality of WL is same, it is equals to selling n per 3. Because V1 and V4 subset of WL by lemma 10, previous lemma, WL is local resolving set of Vn plus 1. Next, because the edge set is like this, we can see that U adjacent to every vertex of WL and V3i minus 1 adjacent to V3i minus 2 and V3i adjacent to V3i plus 1 minus 2. Then WL is dominating set of Vn plus 1. Therefore, WL is dominant local resolving set of Wn plus 1. Next, we will show that WL is dominant local resolving set with minimum cardinality. Choose any S subset of V of vertex of Wn plus 1 with the number of S is the number of WL minus 1. Then there exist two possibilities here. If U is element of S or U not element of S. Based on the possibilities in point A and B, this is contrary with the definition of dominant local multidimension because for U element of S, S is not local resolving set of wheel graph. If U not element of S, we can see that S is not dominating set of wheel graph. So, selling n per 3 is dominant local resolving set with minimum cardinality. Thus, for n more than equal 6, the dim L of Vn plus 1 is equal selling n per 3. This is another result for Jahangir graph. The dim L of Jn, 3 is equal to dominating number. The dim L of friendship graph equals to the local metric dimension of friendship graph. And the last theorem is the DDML of Helm graph. DDML of Helm graph is equals to the number of dominating number of Helm graph. This is the proof. And then for the conclusion, because this topic is still new and needed to expand, so we conclude this paper by giving an open problem. Determine the dominant metric dimension of some product graphs such as Cartesian, Corona, or com product of graphs. This is the references. Thank you very much for the attention. Assalamualaikum warahmatullahi wabarakatuh.